All right, let's dive into a massive shift happening in the world of AI hardware. For what feels like forever, GPUs have been the undisputed kings of AI, but there's a new challenger stepping into the ring, and it's inspired by the most powerful and efficient computer we know of, the one right inside your head. We're going to explore how this brain-inspired approach could literally change everything. So, to really get why we even need a completely new kind of chip, we have to start with the giant, hidden problem at the very heart of this incredible AI boom. All the amazing things AI can do, from writing code to generating unbelievable images, well, it all comes at a staggering cost. The amount of electricity these systems are guzzling is just exploding. It's growing so fast that some experts are predicting that by 2030, AI could be eating up a huge and, frankly, unsustainable chunk of the entire world's power supply. And this slide right here, this puts the whole problem into perspective. Our very best AI hardware is just wildly inefficient compared to the thing that inspired it in the first place. Your brain is doing things that we can only dream of an AI doing, and it's doing it all on about 20 watts of power. That's less than a dim light bulb. This absolutely colossal gap in efficiency, that's the problem everyone in the field is desperately trying to solve. So why are our computers so thirsty? Well, it all goes back to a fundamental design choice made way back in the 1940s called the von Neumann bottleneck. Think of it like this. Your computer's processor is a factory, and its memory is a warehouse located miles away. To do any AI work, you have these little trucks constantly racing back and forth on a single highway, carrying tiny bits of data. The crazy part is, most of the energy and time isn't spent doing the actual work in the factory. It's wasted sitting in that constant, infuriating data traffic jam.
Now, this is where it gets really, really interesting. To solve this problem, engineers aren't just trying to build a bigger, wider highway. Nope. They're designing a completely new kind of factory, and they're basing it on the one that's already inside your skull.
And this is the crucial point to get. This new wave of computing isn't just about going faster. It's about efficiency. It's about being able to put real AI into places where it's just impossible right now. On a tiny battery-powered sensor, inside a self-driving car, maybe in a smart prosthetic. All these places where you just can't plug a massive power-hungry GPU into the wall. So how exactly do you compute like a brain? Well, you pretty much copy its homework. Instead of one giant, powerful processor, you use billions of tiny, simple ones, all working in parallel. And you put the memory right next to the processor. The factory and the warehouse are in the same building now, so there's no traffic jam. But the biggest trick? You get rid of the master clock. In a GPU, everything is on and burning power all the time. But in the brain, and in these new chips, neurons only fire up and use energy when they actually have new information to process. It's an incredible energy saver. And hey, this isn't some far-off science fiction theory anymore. This is real hardware that's shipping today. You've got major players like Intel with Luhai 2, which is powering some seriously advanced robotics. IBM's North Pole chip is designed for things like ultra-low power drones. And then you have innovative startups like BrainChip and SynSense who are putting this kind of tech into cars and smart wearables. It's happening right now. Okay, so this brings us to the main event, the big showdown. How does this new, brainy challenger actually stack up against the undisputed champion of AI, the GPU? Now, before we compare them, we have to understand something really important. We're playing by a whole new set of rules here. It's not about who has the most raw horsepower, what the experts call T-flops. For this new world of AI, the metrics that matter are energy efficiency, how much thinking do you get for every drop of power, and latency, which is just a fancy word for how fast you get an answer in the real world.
And wow, round one is an absolute knockout. Just look at the difference on this chart. For a simple image classification task, the neuromorphic chip used 99.5% less energy. That little tiny sliver of a bar on the right, that's not a mistake. That's a revolutionary leap in efficiency. That's what makes AI on a tiny battery possible.
All right, round two, responsiveness. How fast does it react? For that same simple task, the neuromorphic chip was over 76% faster. And that's because it's event-driven. It doesn't wait around to collect data into big batches like a GPU does. It sees something and it reacts instantly. And for things like a self-driving car trying to avoid an obstacle, that split-second advantage is literally everything. But hang on, here comes the plot twist. When the job gets a lot more complex, like running a really heavy-duty object detection model, the tables turn completely. The GPU's raw brute force power comes roaring back, and suddenly it's more than twice as fast. The thousands of cores in a GPU can just chew through those dense, complicated calculations in a way the more specialized chips simply can't match. So, what's the big takeaway here? It is so crucial. There is no single winner. It all comes down to the right tool for the job. If you're in a data center training a massive model like GPT-4, the GPU is still the undisputed king. But if you're out in the real world trying to run fast, efficient AI based on sensor data, the neuromorphic chip is in a whole other league.
Now, this whole shift isn't going to happen overnight. So what does the future actually look like? Well, the experts have laid out a pretty clear, phased roadmap for how this technology is going to become part of our lives. It's really going to happen in 3 distinct waves. Right now, we are in phase 1, where these chips are finding their footing in specialized areas like always-on keyword spotting. Hey Google, where a GPU just uses way too much power. Then, by the end of the decade, the software tools will get better, and you'll see them integrated into cars and consumer robots. And then, after 2033, the prediction is that Neuromorphic will just become the default go-to choice for any new smart device that needs to run on a battery.
So, let's bring it all home. What's the final verdict? It's probably the most important takeaway about the future of computer chips. The future isn't about replacement, it's about specialization. The future isn't one chip to rule them all. It's a strategic split. The market is basically forking into 2 separate domains. You've got the data center, the cloud, where power is practically unlimited and all that matters is raw computational muscle. The GPU will continue to be king there. But then you have the edge, the real world, your phone, your car, your watch, and in those devices where you need to be smart, fast, and power efficient, neuromorphic architecture is poised to take over. And this right here is what the brain of your future smartphone or your car is going to look like. It's not going to be one master chip doing everything. It's going to be a team of specialists all working together on one chip. You'll have a CPU for general control, a GPU for graphics and computational heavy lifting, and this new neuromorphic coprocessor, whose only job is to handle all the real-time sensory data and run AI with unbelievable efficiency. And this quote just sums it all up perfectly. We aren't just swapping out one piece of silicon for another. We're replacing an entire philosophy, that old monolithic idea that one kind of chip should do everything. And we're replacing it with a smarter, more diverse future where we use the absolute best, most specialized tool for every single job. So the final question really isn't about which chip is going to win the war. The much more exciting question is, what happens when they start working together? What new kinds of applications, what new forms of intelligence become possible when you combine the brute force power of a GPU in the cloud with the hyper-efficient, brain-like perception of a neuromorphic chip out in the real world? That is the truly exciting future that this new technology unlocks.